Thank you, Duan. I'm going to take you on a reflection of work that we've done over the last 15 years related to architecture, both a geographic place but also a material place. And it begins with mankind's oldest manufacturing material, which is mud, particularly from my own becoming mud bricks. And I've always been interested, growing up in mud houses, about the way that technologies come together around this material, which seems in some ways very pure, but because of its purity is infected by the collisions between technology, between culture, between design. And we see, for example, buildings made of mud that are military forts. We see the oldest buildings in the United States and the oldest buildings in the world made out of mud. And it's those collisions that are very interesting, the collisions of technology, when we see that over the time how a building constructed in the 1700s with the arrival of the railroad transforms, and with the arrival of ideas about what culture is transformed as well. And how these buildings give birth to other sorts of designs given transformations in culture. For example, these earthen buildings in New Mexico transformed the moment that people started leaving villages to work in factories into lowriders, taking sort of eviscerating the insides of these churches and taking them on a journey to working in factories and mines around the country. And also how new technologies are being formed to supply the demand for mud bricks for the construction of homes in the Southwest. In my own architecture practice, I've built buildings made out of mud. I think the first adobe building ever constructed out of mud in Marfa, Texas in 80 years, which is in some ways not only architecture but archaeology. And we can see in the archaeology of the house the layers and stratification of geology that comes from the United States and that comes from Mexico, and the performance criteria of that. So the bottom layer of mud is actually much stronger but more expensive mud brick, and the upper layer is less expensive and not as strong but more lightweight, to make buildings that are potentially culturally and environmentally responsive, but also start to question and cross borders between what we think architecture is and what we think art is. For example, this project I worked on with the artist Elma Green and Dragset in 2004 that is a simulation of a Prada store built in the middle of the desert, entirely constructed of mud. My own practice has also embarked on this recently almost completed, it should complete in July, enormous labyrinth made out of 40,000 mud bricks constructed by my own community in southern Colorado. And I've worked on the preservation of earthen buildings throughout the Southwest, thinking about how some of the oldest structures in the United States could be healed and how we understand how we can teach through these buildings history. We can teach indigenous and traditional technologies. Not only building technologies, but cooking technologies, and to think about how manufacturing processes or building processes can be transformative. Recently, I started working with the American Refugee Committee on thinking about how these traditional earthen ovens can be constructed in migrant shelters along the US-Mexico border using an inflatable mold that was manufactured that could be packed with mud around it so we can bring cooking technologies to migrant shelters very quickly in places where people arrive and need to gather around these cooking technologies that migrated from Europe 400 years ago, ways to build community. So Earth has been a big part of my legacy. And in 2008, I wrote a book called Earth Architecture that looks at Earth not as a traditional building process, but as a modern building process, and that modern architecture has been made of earth. In the afterword of this book, I speculated on what might be the future of earthen construction, and I postulated that it might be 3D printing. And I wanted to be the person who embarked on that journey to see if it could be. And the project that we embarked upon was called Emerging Objects. Emerging Objects Foundation, sustainable sources. We could create assembly methods that do not require specialized skills. We could create platforms for software and hardware that place additive manufacturing within reach. and we can consider the connection between pre-industrial, industrial, and digital craft technologies. We can mesh those together so that we can look forward by learning from the past. And in 2009, I began to think about how we can take mankind's oldest manufacturing material, clay, which has been around for 30,000 years, and think about its future. And so some of the earliest experiments were using binder jet printing to make ceramic objects, and speculating on what those ceramic objects might be. Could they be sort of bricks that are slightly more intelligent and hold plants? Could we make insulative bricks or passive cooling bricks that store water in the porosity of the material to cool buildings, as buildings have been cooled with ceramic vessels for thousands of years? But thinking about, in the same way, how you can gather a material from a localized place and build a building with it, what are the other local materials that exist that you might make a building with? And one of these materials in the San Francisco Bay Area, where I was located, is salt. And if you've ever flown into the Bay Area, you see these enormous crystallization ponds, and they're multicolored because of the microorganisms that live within them. But Emerging Objects developed a 3D printing building material made out of salt. And because it was quite inexpensive and had really interesting material properties, we began to think and speculate about what it meant to aggregate those and what it meant to make buildings out of those, inspired by landscapes made out of salt, and also inspired by places in the world where you take the landscape itself to build buildings. How could you make new structures with the materials that are available? So one experiment was I called an igloo made out of salt, a salt igloo, because it was basically made out of salt igloo, made out of a series of components that were binder jet out of salt. And these are all experiments to think about what kinds of structures could you make. Lightweight structures held in tension, a sort of lightweight salt tent, to experiment with the possibilities of creating enclosure using local, inexpensive materials that only use the sun and the wind to generate. Another local material takes on the challenge of the 7 billion tons of wood waste that are generated each year from the construction industry, and how we can transform that into an additive manufacturing material. Again, always thinking about the locality of the material, the sawmills in this case in the Sierra Nevadas in California, thinking about their modularity because of the size of the machines that are available, creating farms of these machines to produce parts that could create walls, enclosures, and building systems. And Emerging Object launched another company called FORUST. And FORUST began to focus on the additive manufacturing wood and explored the ways that binder jet technology could transform wood, not in a natural way, but in a very unnatural way, to emulate the grains of wood, because we could print them within the thickness of the material itself, and to produce different kinds of objects. And I thought I'd show a gyroid guitar, since we've talking about gyroids a lot. I don't know what this might have been made with end topology, I don't remember. But this FORUST is now part of the Desktop Metal ecosystem, and now there are these large FORUST edition Desktop Metal printers that can print these wooden objects. Because this is architecture that we're always focused on, cement is also a material that we've explored. But rather than using large amounts of water and wood to make formwork, how could printing processes make very low water use, formless building components using Portland cement? Always looking forward at the possibility of this material, and always looking back to think about the technologies that have come before us to explore what might launch these materials into the future. But the basis for these explorations is always mud. And in 2016, we launched a project called G-Code Clay. It was the beginnings of a now ubiquitous printing movement in ceramics project, but developed into a project that considered aesthetics, considered structure, considered the potential for how a robot moves, and to think about a new paradigm of design where we are not, as Duan said, designing the object, but designing the toolpath through which the object moves, through which the robot moves, and thinking about their possibilities for enclosure, structure, texture, surface, pattern. And again, always thinking about the cultural implications. And while I was giving a lecture on this back in 2017, the leader of the previous regime had announced, and I was giving this lecture in El Paso, Texas, how there were a lot of bad hombres at the US-Mexico border. And so I thought it interesting to think about how sophisticated that gesture was, that there wasn't a lot of bad hombres at the border, bad men, there were a lot of bad hombres. And bad hombres is this gradient between light and dark. And so I assume that's the bad hombre, and that's a good hombre. So using this technology, made a series of objects called bad hombres, which looked at clays from different political regions around the United States and blended them together to show how a single object can show a kind of heterogeneity, a movement away from homogeneity of materials in the building industry, which asked the question of how can we take the earth from the site. It's not bought in stores at a clay store, but the actual soil from the site to think about how we might build the future. In 2018, we were invited by Google to Mumbai to explore a project called Future Relics, a project that explored the making of a series of objects today that would have relevance 100 years from now. Google had made this program where people walking into the Mumbai Museum could choose the most important word they thought that one should consider in 100 years, and it would imprint it on a digital pot. And then emerging objects would produce those pots for an exhibition that would take place at the British Museum in 100 years. And originally, they wanted us to produce those pots in California and ship them to India, which we thought was ridiculous, and instead asked if we could work with one of the most famous potters in India using Indian clay to develop these pots and work hyper-locally with this potter there, Panajit, who's there showing this clay he harvested in his studio. And we produced a series of pots that had words like plastic or book or cell phone. And after the exhibition, one of the words was 3D printing that should be considered. And these were manufactured with the 3D printer, but also hand glazed by Panajit himself. So if you're around in, I guess, how many years is that, 93 years for the exhibition at the British Museum, I encourage you to attend. That led to a project of thinking about how we can think about the heterogeneity of clay, the diversities of clay that exist in the landscape. And this is a project called Future Ruins that we invited 25 potters between the United States and Mexico, mostly from Juarez and El Paso, to walk along the border and collect traditional clays and collect these diverse complexions and qualities of clays. And we also made available the coding that allowed us to create these highly textured objects. And we created a software called Potterware, and you can see that at potterware.com, that's used around universities and colleges and high schools around the world now. And it was a way for potters to enter into the 3D printed world quite quickly, because potters have a very different skill set. Learning how to model, learning how to slice, learning how to run a printer is very difficult. But this is the underlying basis for thinking about how we can design with toolpaths rather than design objects. And that allowed us to think about how we might create structure at a much larger scale. And so those 25 potters, over the course of several weeks, made over 250 pots using the clay of the local region. So this relationship between the machine, between culture, between place, was carried out in a project called sans les mains. If you speak French, I just butchered that, but without the hand. And we were invited to create a structure that explored this concept of building with France today, or traditionally in France, and used local clays to apply them to this armature that had this highly textured surface that would then create this very stable experimental structure of thinking about how the combination of a very thin bioplastic attached with clay would create a stiffening to create this structure. So many of the experiments led to habitats. Habitats not only for people, but habitats for animals. Habitats that could use these kinds of textures to create cooling shells and structural shells for a very rare bird that's endangered off the coast of California. And so working with scientists, we developed this design for this synthetic bird nests for these birds that have lost their habitat. And some of the criteria was it had to remain a certain temperature, it had to drain because birds poop and pee, and a stray sea lion might lay upon it. So these were some of the criteria for making these. And also, the scientists had to stick their hand in and be able to monitor the chicks. And so these are some of the experiments that are now being studied on the Farallones Islands off of the coast of California. The Academy of Sciences in San Francisco visited and saw these various materials and asked if we could produce coral reef scans out of calcium carbonate. Not because calcium carbonate is a good substrate to grow coral, but in fact they wanted to demonstrate as an educational tool how calcium carbonate dissolves with higher pH water because of global warming. But when they saw these weird loopy ceramics, they mentioned that those were the ideal substrates for coral growth on ceramic, and we produced over 4,000 different ceramic 3D printed objects for testing in places around the world for coral larvae growth. And now these are scattered throughout the oceans in the world with success, with a technique for just being the habitat for a single coral larvae to grow upon. And our goal is to produce 1 million of these in the near future to promote coral reef development throughout the oceans. One example of a human habitat from 2018 was the Cabin of 3D Printed Curiosities, where we combined many of these technologies to think about how we could take advantage of a relaxation in the building codes in the San Francisco Bay Area, where you can now build up to 1,200 square feet without going to an architect or without going to the city and applying for a building permit. So we used that as an opportunity to think about how 3D printing using these kind of techniques could address the housing crisis in the Bay Area, producing ceramic 3D printing cladding materials, materials made out of recycled sawdust, recycled cement, recycled salt, and recycled Chardonnay grape skins from the wineries in the San Francisco Bay Area to make building facades and building components. And this is the Cabin of 3D Printed Curiosities that uses all these techniques, making the furniture, making the cladding, making the lighting systems. I believe you can even see a 3D printed coffee cup made out of recycled coffee. And the various processes that might go into creating a house that's not a singular house made out of concrete, for example, one material, but a house that's heterogeneous, that has many different kinds of materials that apply to our many different kinds of spatial sensibilities: translucency, rough, smooth, soft, hard, and the different kinds of environments and qualities we might want in a place to live. But again, the goal is to think about how we might build at scale using mud. And so many of those early experiments are experiments not thinking about these small objects despite their beauty and their texture, but perhaps this is the goal. And about 6 years ago, we began a collaboration with a company called 3D Potter that manufactured ceramic 3D printers to develop a much larger scale printer to print with earth. The result was this. It's now a commercialized 3D printer that's very low cost, let's say large scale manufacturing of ceramic objects, but also print very large objects. And so many questions were raised then. How do you pump huge amounts of earth through a printer? And how do you increase the quality of a 3D print that's using mud? And what might be the outcomes of that endeavor? Could we print houses in the future that are not made out of concrete, but which are made out of man's oldest building material for housing, which is earth? With the success of the development of both the software, which is the underlying basis for Potterware, the hardware, which is the Scara low-tech robot, and the technologies of pushing mud, in 2019, Emerging Objects started a project called Mud Frontiers, in which the first time in history in the Western Hemisphere we're 3D printing mud that's taken from a local source and deposited right on site. And so many of those experiments experimented with the potential of printing with mud and how it might be different. Many earthen buildings are very, very thick, But because we could corrugate earth, we could print very thin shells. This structure right here is only 1.5 inches thick and about 8 feet tall, and is 5 years old. And last month it sat in a foot of water for about 3 weeks because high snowfalls during the winter created floods in this area, and it still survives today. Printed ideas and thoughts for thinking about how you could print stairways or create insulated cavities for Earth that don't use enormous masses of Earth, but have air spaces and pockets. Began to think about how we might use some of these experiments to make local pottery using local soils, different kinds of structural strategies that are also aesthetic strategies, using local materials like cedar that would bind two very thin walls to make a thicker wall together, but create this kind of texture. And thinking about how we might start to build in program, or what architects call program, places to sit, places to gather, places to work around. And during COVID, when the university was closed and you could go out and do whatever you want, I returned to this very rural environment where I did many of the experiments and did many more experiments, thinking about how we might build vaults or domes or trabeated structures that create openings without headers or lintels. And to think about how that same idea of a low-cost technology could make a very low-cost rail, fourth axis in robotics, placing and moving this lightweight rail in different locations to make a multicellular structure, meaning a structure with rooms. With this inexpensive robot that we're hacking in different ways, we want to print taller, just put it on a big wood box, drive it from the cell phone, dig dirt from just a few feet away, mix it and put it through the pump, and create structural possibilities for 3D printing with Earth. The result of that experiment was a project called Casa Covida. Covida isn't really a word, but it looks like COVID, but it also could mean cohabitation, covida. But it's a house for cohabitation during the time of COVID. And this is that house, which is learning from traditional indigenous technologies, taking Earth from the site, thinking about how you might build enclosures for sleeping and gathering, cooking using traditional pottery and materials that have been used for thousands of years in the region, places for making connections between the earth and the sky, places for bathing. And because many people ask me, well, what about a roof? I thought about what a roof might be in a hybrid technology structure, in this case, an inflatable roof that imparted this beautiful quality of light into the structure, sort of a cherry on top of this chocolate sundae of a house. Last year, I was invited to make a large-scale installation at the Frontier Drive-In. The Frontier Drive-In is in very rural Colorado. It's a 1955-era drive-in theater that's being restored in an extremely rural site. Or large amounts of center pivot sprinklers that draw deep from the aquifers below, producing wheat and barley for some of the beer companies in Colorado, all stored in silos. And so the project is called Skylos. It's, again, this contemplation between earth and sky, these silos of earth that hold the sky in this dark sky environment. And it's the first 3D printed earthen structure that's been permitted in the world and engineered, built with a very small team, 3 people, that uses this very low-cost robot, earth from the site, and a building material that's ubiquitous and free. Just 4 months ago, because of the success of many of these projects, I've had the great opportunity to ramp up the kind of production. And so now I have the opportunity to use this quite amazing ABB robot mounted to a 25-foot long trailer that moves up and down this track, that makes it highly mobile, highly portable, and the potential to build much larger structures far more quickly than I had in the past. And so one of the experiments I just left yesterday was the construction of the world's first Nubian vault. This is a parabolic vault that uses no formwork to support itself. It's because of the paraboloid shape and our ability to print non-planarly. We're testing to see if it's possible to 3D print not only the walls of a structure, but a roof of a structure that has been, like it has been done on this planet for a millennium. So this is the endeavor I'm embarking upon. The idea that perhaps the way forward in architecture is to learn from the past, to think about how we might challenge the paradigms of construction using additive manufacturing today that for 99% of the time are employing a material that has demonstrated to have an enormous carbon footprint on our planet, and instead use a building material that is carbon zero, that is inexpensive, that is ubiquitous, and to think about how we can use additive manufacturing and to think about it in a way that employs traditional and indigenous knowledge to build the future and respond to a very interesting proposition proposed by the Smithsonian magazine on their 40th anniversary when they thought about the 40 most important things you should know about the next 40 years. And the number one thing they mentioned that we should know about is that sophisticated buildings will be made out of mud. Thank you very much.